Good morning, students. Welcome back to science class on the chapter electricity. In the previous class, we had discussed Ohm's law and the very important question, that is V is equals to I into R. So, in the previous class, we had studied one important chapter, that is one important concept, that is a resistor. Okay, so already know it, what resistance? Resistance means it is the flow of opposition of electric current. Okay. uh, in a circuit, if you for example, you have a conductor. If you pass a different voltage for that conductor while taking V by I ratio, that is voltage to the current, but you will get the same answer. So that answer represents what? That answer represents the resistance offered by that conductor. That conductor will resist that current, so that value, whatever it is. Okay. And also, in an electric circuit, without changing a voltage source, we can regulate the current. For that, we use variable resistor. Okay, so why we use that variable resistor? Without changing the voltage, we can regulate the current. Without changing the voltage, we can regulate the current. For that, we use variable resistor. Okay. Suppose here, now I have two conductors. Okay, see, one I will call A and B. I have two conductors, A and B. So now tell me, which one is out of these two, which one is good conductor? Okay. So now I will say this conductor A, it has 4 ohm resistor. Its value is 4 ohm and this is 8 ohm. Okay. Out of these two, which is whether A or B is a good conductor? So put your answer in the comment box. Quick. Okay. First, now resistance of conductor A is 4 ohm and resistance of conductor B is 8 ohm. Out of these two, which one is good conductor? First, I wait for your answer. I'm waiting for your answer. Quick. Yes, Annapurna, you answered 4 ohm. What is that? That is a good conductor or bad conductor? A or B? Mention the name. Just mention the name. This is 4 ohm, 8 ohm. See, resistance means what? It is the flow of opposition of electric current. Okay, understand that definition. So resistance means flow of opposition of electric current. First, I'm waiting for your answer. Quick. Out of these two, which one is good conductor? Now conductor A, it has 4 ohm and conductor B, it has 8 ohm. A is a good conductor. Okay. And Mr. Shreyas, you have answered 8 ohm. No, it's wrong. Yes, A is a good conductor. See here. See, resistance means what? It is a flow of opposition of electric current. So now this is 4 ohm, this is 8 ohm. So clearly we can say that this conductor which offers more higher resistance, okay, which offers more higher resistance. So clearly we can say that conductor A is a good conductor. See, keep in your mind, if you have one device, you have an electric component, if it offers higher resistance, then it is a bad conductor. If it offers less resistance or lower resistance, it is a good conductor. Okay, if the resistance increases, then the conductivity of that material that decreases. Okay. So now we'll discuss two problems. Yesterday I have given one homework for you. Okay. See here. First I'll write the question. So first one, A. How much current? How much current? How much current will an electric bulb, electric bulb draw draw from a 220-volt source. 220-volt source. If the resistance if the resistance of the bulb if the resistance of the bulb filament is 1200 ohm. Then second question, B. How much current will an electric heater coil draw from a 220-volt source. If the resistance of the heater coil is 100 ohm. Okay. See here. First question, how much current will an electric bulb draw from a 220-volt source if the resistance of the bulb filament is 1200 ohm? Okay. So how much current will an electric heater coil draw from a 220-volt source if the resistance of the heater coil is 100 ohm? Okay. So calculate in both the cases we have to calculate electric current. Okay. Yes. Do it and put the answer in the comment box. Quick. I'll give 2 minutes time. So already we know, right, we can relate electric current to voltage and resistance using formula, that is V is equals to I into R. Yes, put your answer in the comment box. So what is the answer for first question? Yes, Bharat Kumar answered, sir. First answer is 6. What is that 6? It's wrong. It's not 6. Yes, Srisha, yes, 0.18 A. No, you can't use small a. You have to use capital A or write it in a word. Yes, the correct answer is 0.18 ampere. Okay. What about others? Yes, 0.18. Don't use a small letter A, use capital letter A. The SI unit of current is ampere. At Srija Guptadhar, I is equal to 220 voltage, equal to that is 0.18. What is that? Idli dosa. So 0.18 ampere. Yes, correct. Anupam Bandarkar. Okay. Yes, the second answer is 2.2A. Yes, correct. Yes. See now first one is the first one. First case. Yes, in the first case, voltage is equals to 220. Then resistance for filament is that is R is equals to 1200 ohm. We need current that is I. So we can relate these three terms how that is V is equals to I into R. We need direct bring R this side that is V by R equal to I, or I is equals to V by R. Okay, so I write here. So V, what is V value? V value is 220, and what about resistance? That is 1200. 0 cancel. So 22 divided by 120, definitely will get I is equals to 0.18 ampere. Why? Because see, I have told right, when a resistance increases, then current decreases. Okay, and resistance increases, then current decreases. Now, second one. The second case also we need see how much current will an electric heater coil draw from a 220 volt source if the resistance of the heater coil is 100 ohm. So voltage is once again 220, then the resistance is 100. We need current. Okay, already the formula is arranged. So substitute the values. 220 divided by 100. 0 cancel. When you divide 22 divided by 10, that is you will get 2.2 ampere. See, earlier you got uh, 0.18 ampere, but now it is 2.28 ampere. Okay, because earlier that resistance was more, so that's why you got less current. But in the second case, the resistance is sorry, earlier resistance was high. In this case, resistance is low, so that's why you got more current compared to earlier one. So clear, right? So when a resistance increases, current decreases. When a resistance decreases, current increases. Next one. I have given the homework for this problem. The potential difference, the potential difference the potential difference between the potential difference between the terminals of an electric heater is 60 volt. 60 volt when it draws a current of 4 ampere from the source. From the source. What current the heater draw if the potential difference is raised 120 volt. Yes. Now find the answer for this question. Quick. Here, the potential difference between the terminals of an electric heater is a 60 volt when it draws a current of 4 ampere from the source. What current will the heater draw if the potential difference is increased to 120 volt? Okay. So earlier it is 60. So in the second case, it is 120. Yes, find the answer for this question. Here, while passing 60 volt, it draws the current passes through that heater is 4 ampere. So now they increase what current from 60 to 120. So what about current? See, when the voltage changes, then the current also changes, right? Because V is directly proportional to current. So in the previous class we had studied that one. Okay. So now what is the current in the second case? Quick. So that is 8 ampere. Okay. So before that, before calculating 8 ampere, first you have to calculate resistance of that heater coil, right? First calculate the resistance of that heater coil. Okay, I'll give 2 minutes time. Yes, the resistance of that heater coil is 15 ohm. Yes, you're exactly correct. Okay, see here. Uh, yes, first write the given data. What is that? First V is equals to 60 volt. Current I is equals to 4 ampere. First, our work is to calculate resistance of that heater coil. See, you know, in the second case also, the resistance remains the same, right? Okay, when you change the voltage of current, but resistance remains same. No? So V is equals to I into R. We need R and bring I this, that is V by I equal to R. So R is equals to V by I. Right here. R is equals to what is V value? That is 60. What is I value? That is 4. So we will get 15 ohm. See, if you increase voltage to 60, 120, 220, 100 or 400, whatever, but you will get the same resistance from that heater coil. Okay, you'll get only 15 ohm from that heater coil. Why? Because why know in the previous class we had studied, right? When you change the voltage, current also changes. But while taking the ratio V to I, V to the I, you'll get the same, right? So here also, for example, first you will pass 60, then you will pass say 100, then you pass 100, then if you pass 120, then 150, then a 200, 220, whatever, the current also changes, right? So then while taking V by ratio, you will get every time 15 ohm only. Okay, because that flow of opposition from that heater coil always that is 15 ohm. Okay, yes. So now calculate what is the current if the voltage is changed to 120 volts. So in the second case, V is equals to 120, then R is equals to 15 ohm. We need I. We need I. Okay. See here. V is equals to I into R. So V by R equal to I, or I equal to V by R. So what is I V value? V value is 120, then resistance is 15. 15 ones are 15, 15 eights are 120. So I is equals to 8 ampere. So clear, right? So clear. So next move to the factors, okay, factors on which the resistance of a conductor depends. So now when resistance increases and when resistance decreases, okay, getting my point? Factors on which the resistance of a conductor depends, okay. You know already, right? For example, take this is a wire, okay. You know, here atoms are arranged. Okay, already you know, right, how electrons move, what will happen inside the wire when you connect to the, when you pass the electric volt, sorry, electric potential difference. Okay, so now this is the wire, here you are connected, you are supplying voltage. What will happen inside the wire? Electrons will move. So while moving, so repulsion takes place, so electrons they will takes place, they will jump like that, they will move. But while moving, some of the electrons they will collide with the neighboring atoms, so that's why resistance increases. Okay, now listen here, see here, I have one conductor, okay, say this is conductor X, no conductor, okay. So now I will pass, say 100 electrons, I will pass 100 electrons. So now all the 100 electrons, all the they should pass us through this wire only, right? Okay, they have area only this much. All the wire, see these electrons, these 100 electrons, they should pass us through this wire only. They have this much amount of space. Clear? Now I will increase the length of the wire. 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 So now tell me what will happen. Whether it is easy flow for electrons, easy or difficult. See, one electron, see, 5 electrons, they will easily jump from here, escape from this atom. But while moving, they should cross all these atoms, right? They should cross all these atoms. If misses here, there is chances for collision here. If this also means there is chances for collision here or here or here or somewhere. Correct? So when you increase the length, then collision increases or decreases? Yes, so put your answer comment box. When you increase the length of the wire, then what are the collision increases or decreases? Quick, I'm waiting for your answer. Yes, when you increase the length of the wire, see that collision, if it misses here, there is chances for here. If it misses here, there is chances for here. If it misses here also, then here is a chance. Correct? So when you increase the length of the wire, then the collision increases. If the collision increases, what is the meaning? Then resistance increases. Correct? Why? Because these 100 electrons, they should pass us through this wire only. If say 5 electrons collide here, then remaining 95 electrons they will move. Okay, they will escape from first atom. Clear? Then what about next? So next again also, say next 95 electrons are remaining. Out of 95, say 3 electrons collide here. Then you will have only 92. Correct? While reaching at the end point, only few electrons are available, right? Clear? So that's why we can say that when you increase the length of the wire or length of the conductor, when you increase the length of the wire or length of the conductor, then collision increases. If the collision increases, then the resistance increases. The first factor, what is the first factor? So the resistance of the conductor, it depends on the length. It depends on the length of the conductor or length of the wire. Clear? So what is the first property? That is length of the conductor or length of the wire. When you increase the length of the wire or when you increase the length of the conductor, then resistance increases. Okay. See now. Say now I will increase the area. I will increase the thickness. Okay. I will increase the thickness. See, so now I will increase the thickness. See, so now here also I will pass 100 electrons. Okay, so now tell me here the length of the wire increased or thickness of that wire increased. So now tell me here for this 100 electrons, see this wire is easy for their motion to travel from here to one point to another point. Well, these electrons move easily through this wire. Say now name of this conductor wire is say Y. Okay. Earlier we have seen what that collision increases. Now tell me in this case collision increases or decreases. See now they have more area, right? See, take one example. You know, just imagine you are inside a class. Okay, 100 students are there in one class. Okay, there are two doors. There are two doors in the class. I will close the one door. I will keep open only one door. Okay, so now I'll tell to the students go through this door. Only one door. For 100 students, that one door is little bit difficult, right? Correct? Okay, some dash occurs, whatever. Some students will fall down, whatever happens. But I will allow one more door. I will allow one more door. Means I will open the two doors at a time. At that time, so little bit easy compared to earlier one. In the second case, students can move easily when the two doors are open. So here also same. Okay. So when you increase the length, then it's little bit easy for motion of the electrons. Then electrons move easily from one end to another end. Do you think that here when you increase the length of the wire, there is no any collision? Collision is there, but it is very less compared to earlier case. So here collision occurs, but it is a little bit less compared to earlier one. Okay, when you increase the thickness of that wire, then resistance decreases. So this is the second factor of resistance. So clear, right? So second factor, it depends on the area of cross section. Okay, what we call area of cross section. Though what is the second factor? Area of cross section. Area of cross section. Area of cross section means here. So now it is a round shape, right? So we call this area is area of cross section. Clear? So thickness of area of cross section. See, first property length of the wire. Then second property area of cross section. But when you increase the length, then resistance increases. When you increase the area of cross section, then resistance decreases. Here resistance increases, but here resistance decreases. So maybe in your exam they will ask how resistance of factor depends on the length. So at that time you should say what? When you increase the length of the wire, then the resistance of the conductor increases. Or in other words, we can say that the resistance of a conductor is directly proportional to the length of the wire and inversely proportional to the area of cross section. Okay, so here when you increase the length of the conductor, what will happen? Resistance increases. When you increase the area of cross section, then the resistance decreases. Clear? It's because now when you increase the area of cross section, then it is a easy path for two more electrons. Okay. So why? Because the collision that decreases. Okay, collision is there. Are you getting my point? Collision is there, but it is less compared to earlier one. So clear? These are the factors. Next. So next one, the nature of its material. For example, see now say this is copper. This is copper. Next I will take aluminum wire. Okay. See, I will take same length and same area of cross section. Everything is same. Thickness, area, length, everything is same. But the resistance is not equal in a copper and aluminum. Already I have told, right? Different components or all the different materials, they have different resistance. Okay, why? Because the arrangement of particles in copper and aluminum different. Clear? Okay, so that's why if you take same length, same thickness, same area of cross section, everything is same, but the resistance is not same. Why? Because the collision is different in copper and different in aluminum. So clear? So that's why the third property is nature of its material. Nature of its material. Okay? Nature of its material. And one more is there. So they have not mentioned in textbook. That is temperature. Okay? Temperature. Already in the in the previous class we had studied. When you increase the temperature, then that resistance value changes, right? So third, fourth one is temperature. But these three are important: length, area of cross section, and nature of its material. If you take copper wire, if you take aluminum wire, if you take silver, if you take gold, those materials, what the resistance is different. Okay. So I will stop here. Tomorrow I will continue the class. Okay. So tomorrow, don't miss it. Tomorrow's class, that is very, very important. In the next class, we are going to study the resistivity. Okay. Thank you.